Welcome everyone. Thank you for joining us for today's webinar. Myself, Dr. Jalada, IEEE BIT branch counselor, will be your host. I am privileged to welcome all the IEEE executive members, respected teachers, and my dear students. Today we have our two alumni of the ECE department, Mr. Vishwas and Mr. Shashank, to give a brief insight about why the participation in hackathon is so important in today's competitive world, and bridging the gap between academia and industry with the help of real world case studies in digital electronics. Mr. Vishwas works as a senior hardware design engineer at Tejas Network. His work involves the design and development of high-speed boards for network applications. Apart from work, he is interested in electronics prototyping, hard and amateur radios. Mr. Shashank is a hardware design engineer at Robert Bosch. He is responsible for the design and development of vehicle comfort, actuators, and motor drivers. He is also responsible for the functional safety moderation for the design of FMEA of ECUs. Apart from his work, he is also interested in International Service Director for Rotary District 3190. Over to you, Vishwas and Shashank.
Yeah, thank you very much for the introduction, and I welcome all of you. I hope your Saturday is going quite normal. And so the agenda for today is what we did back in last year was to emphasize our journey through hackathons. So both me and Vishwas have been of the batch 2018 and 2017 respectively. And so there's one thing that we felt was not communicated well throughout our 4 years of engineering, and we felt that this message needs to go out to every student, because the amount of learnings that we had through the hackathons was unparalleled with any academic work that we did. So I'm quickly going to go through each slide, and we can slowly discuss the benefits of hackathons. Firstly, the hackathon in general is an event where you would be given a problem statement, and they expect you to sit in the same place, be it a particular event organized by a company. They want you to deliver a solution within 24 hours, or some hackathons go up to 48 hours. So the whole essence of an hackathon is you go with nothing and you come up with a product or a solution, present it to the judges, and based on the different criterias, they select the winners. So what advantage the hackathon does, number one, let's start with, is that it helps you to learn with um, time crunch environments. So let's say you all of your students right now, you would first have a lot of trouble in submitting assignments because there's a lot of assignments and there's less time. And when you come to the corporate culture, you would have so many meetings. You would have to end up delivering a lot of content, but you have no time because nobody is going to listen to your explanations in the corporate world. The same with college, nobody is going to listen to your explanations for it. So since hackathon is a time-bound environment, it's 24 hours where you need to brainstorm and completely use all of your energy. You have to probably pull up all-nighters. You don't have to sleep at all. So you get habituated to this work culture automatically. So that's our number one benefit. The second benefit is you tend to become multidisciplinary. So me and Vishwas, we are from different core branches. So I'm from electronics, and he's from instrumentation. So um, the idea is that you might be thinking hackathons are usually for CS graduates. What does a mechanical guy have a role in that? Or you might just say that I do not know a lot of stuff. I do not know how to work with mechanical figures. I do not know how to code, but that shouldn't be your barrier to participate in hackathons, because neither did we. But in in the initial stages it was a barrier, but over a period of time we actually learned these skills through hackathons and not through any official course or any books as such. So being in this environment helps you to grow and be multidisciplinary, and the industry demands such candidates. Nobody's looking for a pure electronics graduate. They want you to be out of the box. So this is one opportunity. Number three is what we always say to each other is that you be good at juggling six balls so that you end up being really good at juggling four. So what happens is, yeah, let's say you have four tasks at hand, or let's say you have six assignments at hand, and you have deadlines, you have home work commitments, you also have some paper presentations, you have a lot of things at hand. So what this hackathon does is exactly replicate that, because in a hackathon, not just your presentation matters, but your hardware should work, your software should be working, you should be having a first class presentation, you should be ready with the pitch, you should know how to talk and present. There's a lot of things and they push it down to you in one day. So if you are good at handling all of that, and when you step into the work culture, everything's reduced into half. So in what you're dealing at an hackathon, just completely, if you trim it down to half, is what you might be experiencing in your day-to-day work. So when you graduate from BIT, you will be like, yeah, I've managed a lot more than what's being offered. So this is what we personally felt even in our day-to-day lives, that we always think that, man, this is way too easier, because in college we were handling a lot of things. So that's coming to our next advantage. Yep. So the next thing is about your leadership and presentation skills. Um, a lot of you might think that I'll be really good at my core fundamentals. I'll be a perfect geek. I'll be a perfect nerd, and I'll know everything in and out of electronics. And I'll probably become Sundar Pichai, or I'll become Elon Musk. But if you look into every person who's been successful today, there were just two things that stood out. If they weren't having the leadership skills and their presentation skills, nobody would have listened to them. So and if you look at it, in your engineering course syllabus, you're only given this opportunity right down in the last semester when you have to submit your project. And because the stakes are very high that time. Usually you might be having a lot of opportunities like small events where you can lead a small team and probably have a small PPT, but the stakes are high in the final semester because you're going to get marks for it, and that finally decides your score. But in a hackathon, you learn this because your stakes are high. One, because if you win the competition, of course, you get a lot of recognition, you get a lot of cash prize. But two is that you learn how to be a leader among your team. So it's need not necessary that every team needs just one leader, but if you're in a group, each one of you takes up one activity. Say one guy says that, look, I'm going to make the hardware design, and one guy says I'm going to do the presentation completely. So you get this opportunity to stand up and be a leader. Yeah, the next point we want to focus here is that don't try to be a sequential learner. Why we say this is because a lot of us wouldn't have this clear vision when we get into engineering, and we follow semester by semester, and from first semester down to the eighth semester, it's a sequential learning that, okay, I know in my third semester I'm going to have digital electronics, and right down till probably sixth semester I'm not going to have operational amplifiers, and probably even image processing is in the seventh semester for me. So don't restrict yourself that I will learn these things when they come, but learn to be open to a lot of new subjects. So as you might me knowing that when back in our days, AI and ML was not at all a term. It was just IoT, but AI and ML was a big take, and people were like, I don't need to learn that right now. So, but then we did explore a lot of concepts in that domain and used it in our projects, and that benefited us a lot, because when these concepts became quite the norm in today's world, we felt like we were a step ahead. We compared to our colleagues and compared to our classmates, we had this notch that yeah, I do not know the entire thing, but I do know a lot of things. So this helps you to stand at an edge even when it comes to your placements. So they do see that, look, this person being an electronics engineer has explored different domains. So yeah, so this is the idea of don't just be a sequential learner, try to explore a lot of opportunities. And coming to the next important aspect is, I think even your class lecturers and professors would emphasize this, that don't just restrict yourself to theoretical knowledge. It's not just about writing the internals and externals and moving to the next semester, but trust me, when you actually do experimentation, when you actually go down to the level of understanding logic gates or understanding anything very simple like an amplifier through hardware, through experimenting it in lab, that thing imprints on your brain much better than actually reading it through text. So this is not something new. This is very old, and I mean psychology. It's everywhere, all around, that you the more you do something, the better you get at it. But the more you do something which has hands-on experience, it creates a certain sector in your brain where you imprint this knowledge for a longer duration. So our idea is that the hackathon allows you to imply certain applications which you study into a real life example, because if you do not attend a hackathon, you do not have the motivation to do so. Because why, you would ask me, like, why should I do it? Like, there's no purpose, there's nothing driving me. But when I say you that, listen, there's an hackathon, there's 25,000 rupees cash prize, and you can get a lot of certificates which will help you in your placements, you have a motivation factor there. And when you start exploring by modifying a lot of circuits, by working on development boards, it helps you a lot. And coming to one of the main aspects here is, don't go behind the buzzwords. So initially I mentioned that AI and deep learning was a big thing, but at the same time there were like blockchain, there was data science. Everyone wanted to get into every sector just by listening to these big words. But our idea is that yes, you do know that these big words exist. You should know what they mean, but just don't fall behind these projects, or just don't fall behind just because someone is working on it. These technologies over a period of time would eventually die out, but what wouldn't die out is your core fundamentals. So always accept the fact that you need to have a really core fundamental, and be good at experimenting with basics, and then you can jump to these applications. So um, many of us actually just get fascinated by hearing autonomous cars, and we are like, yeah, let's try to do something on AI and machine learning and stuff like that. But downright, if you just come down to the discrete components that are being used in machine learning, you might start to look at things differently. So get your fundamentals right and then move on to these buzzwords. Yeah, and coming to my conclusion is that grades don't matter. I think the professors wouldn't agree with me, but they do not matter to an extent, but they actually do. Now you might be like, why is he just confusing us? In reality, what I want to convey here is, you need to understand there's a thin line between what grades can do for you and what your own knowledge can do for you. So don't just become a rote learner and just try to score marks just for the sake of getting marks, because end of the day, yeah, they do count during your placements. But our idea is that don't just stop because, okay, you'll be like, I have exams in the last month and I do not have the time. So just don't make grades a barrier for you, m- because end of the day, it matters how you use these knowledge into your practical applications. So don't restrict yourself like, hackathon is next week, I have an internal next week, I cannot do it. No, just don't do that. Grades can be managed over a period of 8 semesters. We're not saying completely ignore them. We're saying, yes, you manage it and eventually you can build up with it. So Vishwas will take over and explain you a few of our projects. Vishwas, you can take over.
Yeah, thank you, Shashank, for the quick review on the thing. So yeah, hello everyone. I'm Vikas. So yeah, if someone is on, someone's mic is on, can you just please mute it? I guess some cricket match is going on. Yeah, yeah. So yeah. Okay. So I'll just quickly go through all the projects we have done for the hackathon purpose and yeah, even for the brainstorming and everything. So I'll just quickly go through this. So this project is called Aggro Squad. So basically, it's for as you can see, it's for agriculture. So what the whole idea was we the ideation of the whole thing was happened in the quadrangle only. So we me, Shashank, and two more guys from mechanical and information science. So we just brainstormed and we started developing this project for one hackathon, and later we evolved and we were able to pitch the same thing for two more hackathons, which are having the same agriculture innovation as a theme. So basically, this system consists of in a huge farm where in which there are multiple crops being grown. So you can use a number of sensors and IoT for them to get the exact nutrients required for a particular plant, and also other constraints like what like the humidity levels required for that plant. All those things you can get. And so the interesting idea here is we have used one Wi-Fi based chip here, and we established a, star kind of communication where in which it can communicate to other this thing, and the centralized node will get all the information which will directly upload it to the cloud. So each sensor will not talk to the cloud, so each will talk to the next nearby sensor, and altogether we'll aggregate all the data and send it to the cloud. So that was the idea behind the data acquisition through the sensors. So by this, we'll be able to locate the exact particular plant which needs particular attention, like that. So the idea of using drone here is currently drone being used everywhere for all the image processing purpose and all. So here in this application, we are using drone for the image processing of the crop plants and see whether we need to spray pesticides for that particular plant or not. And we are geotagging the location in a large field with open area. You can use a GPS and use them to map the coordinates where in which we need special attentions. In the right, you can see the video where in which cabbage plant is being shown, where in which some plants are like through the image processing, we'll be able to aggregate the data and see that needs special attention. So we can only take first we'll do the survey of all the field, then we'll use the pesticide canisters with the spraying mechanism to go there and spray the pesticides only to that particular plant which needs the special attention. So in this way, we'll reduce the total consumption of harmful pesticides per acre of a plant and per acre of agricultural land, so that we can even reduce the harmful substances going into the plant, like that. So this is the whole picture behind this. So some important aspects in terms of design of this units is like, so since we were from multiple disciplinaries, one came up with the idea of using drone, and one came up with an idea of using a sensor probe. And since one other guy is from a computer background, he pitched about the image processing, what his expertise is. So, and other guy came up with an idea of spraying the pesticides through the robotic arm, which can protrude from the drone and spray it on. So those are the advantages of having multiple disciplinaries in a project. So, and also we were able to get a very good battery time for these probes, because these needs to be there in the field for a long time. So with the help of like deep sleep mechanism and all, we were able to run this probe for like months with a single battery running in. So for this project, we as time goes on, so we evolved and like we pitched for many competitions and all. So here in the right bottom, you can see that we were one of the teams which qualified. Like only 3 teams from India got qualified this competition. Out of 907 team, we were one of the team which represented India. So this was from BIT when back in the 2016. So this was the project about Aggro Squad. So I'll move on to the next slide. Yeah. So okay. Yeah. This project is called Umwelt. So Umwelt in German means environment. So this is like an IoT system. So right now, like there is a craze for all the home automation and IoT system, wherein which like everybody has their own home assistant kind of device, like Google Home or Alexa or something like that. So the main problem with these things is these work on Wi-Fi networks, which is vulnerable to the attack. So currently there is no or very less security for these devices. Like someone recently hacked Google Home through just using laser lights. So directly using laser lights on the microphone of the Google Home, so they were able to get the access without even giving the voice command. So amplitude modulation of that particular laser beam on the microphone resulted in a certain voice command, and they were able to control the garage doors, lights, and all. So these are like hacks which can be done physically. That means that someone should be there at a near distance to do this. And there are hacks which are done through the network also. So the idea for this project is like an RF based system wherein which where the whole all the sensors, these modular sensors, are being controlled using an RF based system, which is not hackable as normal Wi-Fi based system because it is not getting connected to the internet. So this whole system will, in the bottom, what you can see is a phone case actually. So it's a phone case with all the required electronics. It's an inside of the phone case. So we made this project as a prototype. There's all our projects are kind of proof of concept just to prove that this works as a product kind of thing. So yeah, so this had an RF based communication system which talks to all these modular sensors and actuators. Actuators in the sense like you can see there is a plug being shown there. So which is an AC plug, but which is a smart plug which is being connected to this smartphone case, which uses an RF interface. So our thing will whole IoT system will be secure and we'll be able to scale it also because we'll be using different kind of RF mechanisms and encryption for them. So that's why we'll be able to scale it also. And the modularity is one more thing here. In the second image, you can see there are multiple sensors being used, and in the first image, the first module has all the required pinouts for them. So any sensor can be plugged into any module work to work it as like a proper IoT system. So this is one of our pitch for one of the hackathons. So we were able to get some good prize in that. Like maybe if I remember, it's second prize or something. It was an international hackathon. So yeah. So the concept of what I'm saying is you should instead of replicating existing thing in the market or in the this thing, so you should brainstorm and get into a new idea and see what are the advantages. Just do a SWOT analysis, like strength, weakness, opportunities and threat analysis of what can be done and what cannot be done, like that, and then you'll end up in a better product with all the required things. So it is not important to have multiple features, it is just important to have important features. So those are the main takeaways from this kind of project. So yeah, let me go to the next project. So this project is called Drix. So this is for advanced driver assist system, a kind of ADAS system for car. So currently there are a lot of self-driven cars around us, like maybe Tesla, or companies are developing different technologies for self-driven cars and all. So this is a compute module which can be plugged into a car, which will make them as a smart car. So there will be multiple sensors, like camera-based sensors, and sensors on the like steering and all. So basically, the even normal cars will have around 40 kgs of wires running around just for the sensors connections and actuator connections. Shashank could be knowing better about this than me. And also, like if you consider, if you join each wire length to length, you can imagine it will reach a length of around 2 to 3 kilometers. So that much amount of wires are already being present on the automotive system. So we will be tapping these sensors through the like a debug port of the car. There is something called as onboard debugging, OBD port. So we can use the sensor data from there, and our compute module will be able to completely guide the driver in an early stage, or also it can work as a assist for him. So that, like, if he in a situation where in which he needs a rest or something like that, he's been tired of driving, so sensors on the steering, maybe a capacitive sense on the steering, can predict his stress levels based on his galvanic skin resistance, and it will be able to inform the driver saying that you need to take rest, like that. So these are very important features. Like, most of the accidents happen due to human errors, or falling asleep or something like that. So that is one thing. In the right top, you can see there is an image processing going on. So this is a driver's eye closure being recorded. So using certain image processing algorithms, we are using a camera-based vision system. So it will directly detect the eye closure of the driver. So if it is closed for a certain period of time, so we will be stopping the driver. So here in the through the Need for Speed game simulation, we are just showing that how the whole process happens and how the car will be stopped. So this was just a simulation being used with the help of multiple softwares and hardwares. So yeah, the overall architecture had a Raspberry Pi which has connected to OBD port and external sensors, and some image processing going on, and all those things. So we pitched this for a competition, and so this was like a 24-hour thing only. So we were able to come up with this solution in 24 hours only. So based on the problem statement, you need to brainstorm and look for the current alternatives, what and all are there, and do a SWOT analysis of the current alternatives. Well, like, why it is failing and why it is hard to implement, and what are the disadvantages. Just look for that and try to correct them in your prototype and pitch them like that. So that is the main goal behind winning a hackathon kind of thing. So yeah, so this is our next project called Seaver's Way. So basically, currently the situation is like in India, even though the manual scavenging is banned, very like in the 2013s only, but it is currently being practiced because there is no other way of cleaning the manholes. So there are robotic methods also, but still there are situations where in which there are huge rocks and all, or some drainage blockage will happen inside the manhole, which needs manual inspections only. But the problem there is due to the garbage. So there is an accumulation of huge amount of methane gas. So whenever someone enters the manhole just to check what's happening, so he might suffocate, and even this may cause to the death of the person also. So there is no current solution for this kind of thing. So we, as a team in a hackathon, for the same purpose. So we are made a small sensor-based unit where in which it can detect the level of water inside the manhole. So based on that, with some basic machine learning algorithm, we will be able to see whether the raise of level of water is normal, or can we see some anomaly in that. So if there is a blockage, there should be some raise in one particular manhole than other manholes. So comparing that data, we'll be able to see that we can even pinpoint the location of the blockage based on the water flow. So basically we use some distance sensors here with gas level sensors just to make sure that the gas level is above some threshold or below some threshold. So these data is currently being sent to the smart street lights, which has the LoRa gateways on it. So this will be part of a smart city architecture in which all the street lights will be controlled through LoRa. So LoRa stands for long range. Basically, it's a technology which is being used for the sending and receiving sensor data for the large long distances without any with using a little bit very less amount of the battery power. So that is the funda behind this LoRa. So we are using LoRa for the communication from the man. So the whole device will be fit inside a manhole. So the manhole cover will contain this device. So which will continuously measure the water level inside the manhole and send the information to the nearest LoRa gateway. Through the LoRa gateway, we'll be sending it to the cloud. So after the hackathon, also we evolved from the simple proof of concept to the product. So you can see that in the first one, you can see there is a tic-tac-toe box, which is just for the proof of concept, having two sensors and a microcontroller. Then we evolved into a LoRa-based proof of concept the next day. Then 3D printed it, and here you can, at the left bottom you can see a proper enclosure 3D printed with the help of 3D printer, and also a LoRa communication antenna you can see. So this is the way to approach a product and create a product out of it. So that's all we have for this. So as Einstein told, you should never stop learning. So yeah, thank you, Shashank. I
Yeah,
think you can.
thanks, Vishwas. Yeah, perfect. So our whole idea of showing you our projects was to just to show that you do not have to limit yourself to a particular branch, and you do not have to just stop yourself to go to a hackathon because it was an entirely software-based hackathon or not. As you can see, the the Drix system that we built, the problem statement given to us was build up a solution for connected cars and connected mobility. So just by hearing the word connected mobility and connected cars, we had to brainstorm as to how can we pitch in hardware, how can we pitch in software. And over a period of a few hours, we just glanced through everything we can do of image processing, and we just got the idea that a lot of accidents happen because the person sleeps, and why not let's detect the person's eyes and simulate that on a game. So these kind of ideas might seem like it's really difficult to attain, but my suggestion would be find like-minded people in your class, or even step out and try to go beyond your class. Um, and visit a lot of hackathon websites like hackster.io, hackathon.io, Hacker Earth. So there are a lot of websites where they keep posting these on weekly basis, and you do not have to participate in all of them, but get an overview of what is the theme, what do they ask, and probably just register. Your first hackathon is going to be the toughest hackathon for you because it's going to be a first time experience, and you will see a lot of people around you who are like non-stop working 24 hours. They'll not even sleep. A lot of people just sleep on the floor for 2 3 hours and they do it non-stop. But then trust me, me and Vishwas would probably agree with this. It's like an addiction. You really get addicted to this, to the hackathon culture. And there was a point of time in the final year where we had a lot of time in college because classes were quite limited, but we didn't have much to do. And hackathons helped us finish our final year projects much before because we had covered so many projects that final year project was a easy walk-in for us because we knew what we wanted. Since you guys, I've heard that most of you are from third semester. Um, I think this is the best time to get started. Um, um, just follow up with us if you feel like, how do I get started? Could you share a few projects? You can go to Vishwas Instructables page. He's created a lot of projects on Instructables. So one thing you can do is even go to a website called instructables.com. A lot of people put up their projects there, and everything's open source. So you can just take their code. They'll give you a complete description of the hardware being used and replicate it. You can start off with replicating projects, and yeah, I think all of us have this end goal of one day being placed in a very good company and probably use what we have learned. Because there are few people who actually end up with 4 years of engineering and sidetrack into a completely different domain. You wouldn't want to do that if you are actually into electronics. I mean, you spend 4 years, you would want to actually make use of every single. So, yeah, signing off and saying that hackathons really do change your entire engineering life. So, do give it a try. Yeah, thank you. And if there's any questions, we'll take them now.
Participant, if you have any question, please interact with the speaker. So thank you, Shashank and Vishwas. So can you brief what exactly tomorrow you're going to highlight?
Hello.
Yeah.
I think there's a question, ma'am.
Yes, Balaji.
Bro, when did you get started, bro?
So
When was the
actually, we
time that you
start.
realized that we have to do that?
Yeah, if I remember correctly, it was the end of second semester, right, which was second
Yeah,
semester. Yeah,
yeah.
yeah. We used to see these college fest in other colleges, and they used to have these technical events where they also mention hackathons. So we just walked into one of the hackathons in RV and Dainand Sagar and got a glimpse, and we are like, okay, every other college it's happening in very large scale, so let's just get started in this.
So Vishwas and Shashank, can you brief what exactly tomorrow sessions
Actually,
is?
ma'am, we will be covering it today itself.
Ah,
Um, like I messaged you that we'll be covering it today.
hmm.
So,
There is no sessions tomorrow.
no, we actually had some other work tomorrow, so we'll do it today itself.
Okay,
That's
thank you.
fine. Yeah.
Yeah, I have one more query. So,
Okay.
how exactly the student can apply for hackathon competition with different countries? Is there any such website is there available, or how exactly
Okay.
can
Yeah.
they
So
can register? Yeah.
these international hackathons are usually hosted online. So one website is the hackathon.io. So that is by a company called Angel Hack, and even in Hackster.io, these two companies have hackathons hosted by international companies on their platform. So the first round of an hackathon is generally where you need to pitch in your idea. You need to give in a synopsis, 100-word synopsis, and if they like your idea, they let you go to the second round where you have to send them your hardware solution, send them the code, and show the working. And if that goes well, in the third round, you have to present your idea to the judges, where it's like a 10-minute round with the judges, where you get 8 minutes to present your idea and 2 minutes for Q&A. So international hackathons generally happen like this, and some hackathons have their finals in the host country. So if you actually come up to the finals, they fully fund your tickets and you can go to the respective countries.
Thank you.
Yeah,
Any other question
Okay,
from
one
the
more
students? Yeah.
question, bro.
yeah.
Did you have any specific skill set before joining your first hackathon?
No, we were like a complete open book. Literally, we didn't know anything. Like we just walked into just to understand what can we do for 24 hours. And in the 24 hours, we sat and probably had 8 hours of YouTube videos understanding what is what, and 3-4 hours of teaching each other, okay, this is that concept, this is the final concept. And I think we didn't have a proper hardware, but we just had an idea in mind and we presented it to the judges. So the first hackathon is going to be really tough because you'll not know what you expect. So just go for it.
Any other question from the students? Can feel free to interact with the speaker. If not, okay. Thank you very much, Shashank, as well as Vishwas, for your fruitful information about how exactly you can get into the hackathon competition. So thank you for your motivation speech about this hackathon.
Yeah.
So thank you once again. Thank you, and all present here. Thank you.
Yeah, so we will just continue with the second session now, if that's okay with you, ma'am.
Yes, no problem.
Okay, fine. So, so the second session was just planned to divert a little bit away from the hackathon and explain to you guys, since now you're entering the core branch as such, um, how do you actually bridge this gap between academia and industry? You would know that you get into a job and you really don't know which particular subject is going to be used finally in the end of the career. And what we're going to just talk about here is just highlight what you need to understand and what you need to grasp. And this is not a foolproof method. You can always stick to the traditional method of studying for the exams and sitting for the placements, or you can be open to options. So this is just a particular way of how we handle things, and we are going to discuss a few cases of digital electronics in the real life. So our intention is probably to help you how to um, try to understand whatever you study is being used in the industry. So if everyone has access to the chat, could you just tell me at home which device do you think would be using digital electronics in it in the chat option? Could everyone just type whatever comes to your mind that this device is definitely going to use digital electronics?
I request students to type in the chat window. I think everybody can access the chat window.
Yeah. Yeah, perfect. That's right, Navya. Washing machine. Yes, computer is absolutely right. Watches is also right. Microwave is right. Remotes is right. You guys are like nailing it. Perfect. So, in essence, if you think of digital electronics, every application at your home appliance would be using this. And so that's where you understand that being an electronics engineer, uh, when you study digital electronics, when you finish that book and you finish the exam, you must be like, yes, I do know in this appliance where it's used. I can clearly tell in a microwave oven, this is where it's used. So that's what basically engineering wants to get out of you. But yeah, people would probably just study for the exam and move on. So yeah, that's our focus here. So there are a few questions that come to your mind while studying probably any new subject in each semester. One is that what is the concept that is being actually used in the real life? Like if I tell you about encoders, decoders, you'll be like, okay, fine, I know about what an encoder and decoder is, but where do I actually see this in real life? So this should be a question in your mind when you're starting through something. And second thing is, how do you move beyond textbooks? So a lot of you might be like, we have textbooks, we study the same thing, and that's our syllabus. How do we go beyond this? And third is, do we actually need to know about each and every fundamental when we get into the work environment? So you might be like, it's a 400-page book. It probably covers everything all the way from Boolean algebra to shift registers, A to Z, everything. But how do you know what is actually going to be used? And what is the idea of practical study? That's basically what we referred in Hackathon as to getting your hands on dirty. So, yeah, I'm pretty sure all of you would have seen the syllabus of digital electronics, and all of you might be in the state of mind like this person here and be like, okay, there are a lot of topics, but I really do not get a lot of it. And why is it useful to me? So, I'm just going to show you one approach and just recommend it to you that whenever you come to a new topic, associate it with examples in real life. When you actually associate each subtopic like binary systems, Boolean algebra, or code conversions to an actual example in real life, and trust me, in the textbooks, you'll not find these. They rarely talk about real life applications. So when you actually see that this is being used here, you actually get to associate things much better. Like all of you have mentioned washing machine. When you actually go back to the when we're going to discuss about washing machines later, when you really come down to a washing machine and see the counters being involved there, and then you see, oh, okay, I studied the same thing in class about counters, and they're using the same logic here in washing machines. It helps on another different level because during your placements and during your interviews, nobody's going to ask you straight down, tell me what an SR flip-flop is. They're going to see your application-based knowledge. How well do you know to solve problems? So if you just look at binary system, the first topic itself, you're going to learn a lot of topics like conversions, a binary to a hexadecimal, and then two's complements and ASCII codes. Um, you should just think about it. Like the way I envisioned a binary system was, I just read about it that initially back in 1940s, binary system was what is being used, and it was it's very difficult for someone to actually make sense out of binary data. If you tell me a number which is like 344 in binary, if I look at it, it's not making any sense to me. And then came the era of decimal where everyone actually studied the decimal system of counting. But then when computers started getting more and more complex, we realized that 10 digits to represent a particular from 0 to 9 to represent a value isn't sufficient. So we wanted to increase our density, higher information density. So we used something like hexadecimal. So I had this thing stuck in my mind that hexadecimal was used to represent a lot of information in less digits. So as you know, in 2 digits of hexadecimal, you can represent from 0 to 255. So I had this fit in my mind, and I knew the application is going to be in computers. And whenever I was solving a problem, a particular or reading through the concepts, it was very easy to associate. I was like, okay, yeah, maybe the computer needs this adding to be done, and that's why hexadecimal was used. So when you realize there's a purpose for every um, concept being explained, it becomes more and more interesting. And second thing was with Boolean algebra. So I'm very sure everyone knows AND or NAND gates. These are very basic. But when it came to XOR and XNOR, and they used to ask us to realize these through AND gates and OR gates, a lot of my friends used to be like, man, I'm just going to memorize the block because I'm not understanding anything and it's just going to be asked once. But when the way I looked at it was put it into an example. So these examples you will never find in the textbook, of course. For an XOR gate, you can think of it like a buzzer game. So if imagine there are two contestants here, they're like this three, and you want to select only one contestant. So that's the whole essence of XOR, that it will only one should be allowed, and otherwise if both press, it's like locked out. Both of them are not counted. So if you associate just the buzzer word in your head with XOR, You do not even have to remember the table for XOR gate. And the same thing with street lights. You would have noticed that a lot of the street lights now in Bangalore and smart cities, they're automatic. So you would be like, okay, they must be doing some signal sending, nothing. They're just measuring the light intensity and they're putting a NOT gate there. When it is too bright, put a NOT gate so the lights are off. Means when there's sunlight. And when it's dark, since there's a NOT gate, turn it on. So the idea was, if you associate with such examples, it's very easy to move forward. And coming to Boolean functions, about K-maps, you'll be reading about De Morgan's theorem, don't care conditions. Um, if you just understand this washing machine example, right? Trust me, this topic is just done. You if you understand it today, you do not have to worry about tomorrow. And we'll come up to this in the future slides. And the next topic is about code conversion in digital electronics. And uh, I had this three notation of associating BCD. Whenever I hear the word BCD, I used to associate it with a 7-segment display. So if you can picture the 7 segment display and how each character is being eliminated, it becomes much easier to understand the purpose of it. And same thing with gray code and XS3 codes. We will come to these in detail in the future slides. But again, the essence here was to convey the fact that for a first timer, when you study, when you're even preparing for exam, you will be like, what is this? Why do I need to know gray? Why do I need to know XS3? And you have to memorize a lot of things. So, but if you associate each thing with a example, it straightly strikes to your head. BCD, yes, BCD is the 7-segment display. I know what to add and what to subtract in this logic. And encoder and decoder. So I think most of you roughly know what an encoder and decoder mean, but the only idea that you keep in your head whenever you're talking about encoders, so you will have these decoders, 2:8 decoders, and you'll be like, okay, there's 2:8. I need to split the channels and I need to do. Don't get into such details. Don't remember those specific decoder examples, but just fit the simple ideology that decoder does decryption from decoder to decryption. So you know that there's a binary data and that translates into a message. So your whole idea is that if you have some data, you're trying to expand it into something sensible. And the same goes with encoders. If you just keep the mind of encoder with encrypt, E and E, and you remember this picture in your head that what I'm doing in encoder is essentially I'm putting a lot of data into my existing message. I'm stuffing it with unnecessary redundant stuff. And someone in the backend has the information what this redundant stuff is. So he will cleanly remove out only this redundant data and he will get the message securely. So try to picturize the same here. And um, coming to this, I'm sure like a lot of us, this is like in VTU short question, which is going to come explain JK flip-flop, D flip-flop, T flip-flop, one of these for sure. And these are the diagrams, and we always used to be like, okay, where is J and K connected and where's the AND gate? How I utilized it is I studied this case of token number system. Like how do they actually update this token numbers in banks and in Domino's? When you sit and you see these display, they have this token number system, right? So if you given your interest, your personal interest, and you start figuring out, okay, how do they actually do this circuit then becomes a walk-in cake. Like it's like super easy for you. I might be sounding like a person who's like just telling a lot of things is very easy, very easy. No, it's not very easy, but there are ways to make things easy. Uh, Compared to a traditional way where you would just open the book, have a table for a JK flip-flop and see this diagram. My idea here is associate it with an example, study about the example, like how does it work in real life, and then your memory works in a way much better because it maps images better than text. So whenever you see a JK flip-flop in your exam, you remember straight up the Domino's counter picture, and you know the research that you had done to understand how it works. So that way, this helps you in academically better, of course, yes, but also in your career, where because a lot of these concepts you tend to forget. Even us during our work environment, we sometimes forget certain basic things. Common collector configuration, we have to just remember it twice, or maybe you have to do a Google search. So the way you study few things can impact how you recall things in the future during your work environment. And yeah, Vishwas, you can take over with the case studies.
Yeah, thank you, Shashank. Let me go through the practical applications and real life scenarios where in which these things what we learn on digital electronics is being used. So in here you can see a picture. Where have you seen this picture? You can type in the chat windows. So where have you seen these kind of speed measurement devices? So like these are basically speed measurement. Okay, yeah, MG Road, one answer from Balaji. Yeah. So MG Road, Airport Road, where in which the speed vehicles are speeding above the speed limit. So this is being used, and just to like, and sometimes you may also see that traffic patrol vehicles will have a mounted radar on top of their vehicle, which will be sitting near to the edge of the road and catching everyone for overspeeding. So basically, how this works. So yeah, like what's the digital electronics inside this? Can anybody think of it? Like, what's the basic funda here? Like how the whole thing works? Like maybe what major concept of digital electronics is being used here to get the speed of a vehicle?
Velocity.
Yeah, the like finding the velocity is the main thing. But how do you do it? Like, what is the application of digital electronics in that? Okay, so yeah, I'll show you. So the basically there are multiple ways to measure the speed of a vehicle. So
Sending a high frequency signal and
yeah,
counting back
uh,
at what delay it came.
yeah. So basically, we'll be using timers and counters in terms of like digital electronics perspective. So there are multiple ways of using sensors and actuators in this purpose. So one is using the Doppler radar based method, where in which you will send a high frequency radio wave through a high frequency radio wave through a gun, which will directly hit on the vehicle and come back, and you'll be able to read the value, and you send again, so you'll see the value again. So difference between those two times and difference between the distance will get to know the speed of the vehicle if you directly simply divide it by the time. So you'll be able to see like this much distance has been covered in this much amount of time, so this is the speed of the vehicle. So you'll be able to see that using the uh, this radar based method. So this same application can be used in terms of light also. There are lidar based speed guns are there. So and normal laser based speed guns are there. So here is an example of like optical speed gun, which is directly, you can see that's a simple mechanism here. So light is being used to read the speed. So it is directly hit and come back, and so we'll note one time and we'll again hit and come back, and we'll note one another time with a smaller distance at this point. So we'll be able to see the time difference and distance difference, and you'll be able to calculate the distance. So basic idea is using timers and counters. So one thing which we need to observe is like there will be a dedicated timers and counters for this purpose, which will be inculcated, or which are like implemented inside a microcontroller kind of thing. So microcontroller will definitely use this kind of timer and counter for this purpose, which will start counting and it will stop counting, and it will be definitely be able to calculate the accurate speed of the vehicle, which is approaching the radar or the speed gun. So this is one way of looking at the problem. So yeah, there are the same thing is being used for all other purposes, like even sonar based ranging, lidar based ranging. All those things use the same timer and counter concept in core with a very high accuracy to get the value of the distance or the speed or something like that. So this is one thing. So in the second case study, I'm going ahead with uh, intersection management. So if you think of a traffic light system, so there are multiple ways which is being monitored. So one may be a simple fixed time interval based traffic system, where in which each road will have this much amount of time to pass the vehicle. Let's say 30 seconds for the green light and rest 30 seconds for the red light. So these things will be there, and there is a transition time of around 1 second between amber to red and amber to green, like that. So the problem here is, even if there are no vehicle in one road, so but since the time is already fixed, it will be running the counter. So that requires a manual intervention there, and people will start honking. You may have seen in the Bangalore roads. So since there are no vehicle, but still the signal is green, people will start honking. So the person there sitting there, if someone is there monitoring the signals, he will be manually turning off and turning on and changing the signals. So this is one way of looking at it, and another way of looking at it would be using adaptive control systems, where in which it will take a photo of the road, or maybe use a sensor and take the sensor value till what extent the vehicles are being like there on the traffic. So based on that, it will directly switch over the time. So if there are no vehicles on that road, it will reduce the time to maybe 5 seconds or 10 seconds for the green light. So that's another way of adapting the traffic light system, where in which it is like more intuitive, and it will be helpful for everyone also in saving the time. So what digital electronics concept here is finite state machines. So maybe you might not have come across this currently, but you will come across this in the when you study about this. So for a fixed light traffic control system, so you can see that in the right side there is a finite state machine diagram, where in which TL is a time long duration, and TS is a time short duration. So TL basically means like maybe 30 seconds in terms of green light. So that is the first green light, where in which it will start for the this thing, and other lights are red. Like for example, north south is there and east west is there. So it should block lights on the it should be red on east west road, and it should be green on the north south road. So based on that, this whole finite system finite state machine works. So first it's a sequence of operations repeating in a loop. So this concept of finite state machine is being adapted for a fixed traffic control system kind of thing, where in which the time duration is being fixed. And this works perfectly fine when the density of vehicle is normal. So if there is a variable density, like one road is having less density, which will not lead to the major city traffic, so then it will be having less traffic. So whereas other road, which is maybe east-west road, might be having more traffic, then this won't work. So the fixed control system works best in the where in which city central junctions, where in which number of vehicles on either side of the road, like east, west, and north side or south of the road are perfectly in balance, then fixed control system works perfectly fine. So for these kind of fixed time control systems, we can use these kind of finite state machines, where the basic backbone is finite state machines. So there are like a lot of evolvement in the terms of traffic light management system right now. So currently, all traffic light systems are controlled through a central station, where in which it will have the access to the huge computer computing all the directions and time required, delays and all. So these are like we can say the early stages of traffic lights. You can say. So the basic idea is here the simple finite state machine can be implemented for a traffic light system. So these finite state machines can be realized on a microcontroller for a project purpose, or a FPGA, or anything like that. FPGA is field programmable gate array. You might come across this in the future classes or future semesters. So which will definitely help you to realize basic digital electronics logic gates onto a whole big level circuitry. So these FPGAs are, I'm just going to tell basic brief about FPGA. So like whenever you have a large scale enterprise and you are, let's say you have a company which is manufacturing a certain electronic product, but you are selling it a larger number, saying like 1 lakh or so plus. So then you can easily go for that particular application. So then you will go for application specific integrated circuits. Or in some cases you will not be having such a large numbers, but your each individual system will cost more. So in that case, you cannot go for larger number because each individual FPGA or brain of the circuit will cost more. So you'll go for a FPGA. FPGA is like you can whatever you want, you can create on that device. Like basically, you can create a ARM CPU onto the FPGA. So and it is completely rewritable. So once you power off and power on, whole configuration goes off, and you can directly start a whole new configuration like that. So FPGA will help you in the smaller scale products, where in which you will have like basically network products where the cost of the product will be in crores and you'll be selling only few thousands of them. Then you will definitely go for FPGA than an ASIC. So that's the difference between FPGA and ASIC in terms of requirement purpose. So that is about this finite state machine and this thing. So let me go to the next slide. Yeah, so we talked about this thing. So how we are using digital electronics in washing machine. So you might have seen a lot of washing machines coming with electronically controlled and all. Like there are multiple like washing machines with like automatic, semi-automatic, front loaded, top loaded, all those things are there. So as and features get increased, you will have to deal with more variables to control. So basically the variables to control will be your tap, water inlet, whether it is hot water, whether it is cold water, or this thing, rotary pump, which is pulling the water in and which is pushing the water out, and also the main motor of the washing machine, which rotates to uh, rotates the whole drum of the washing machine to clean all the clothes, and all those things are there. So basically there are multiple ways to control. Like the main control variable for the motor will be the RPM. So basically RPM will be controlled through PWM, the pulse width modulation. So like that. So basically you'll be having multiple control variables, and how will you realize that using a simple digital electronic circuit? So we'll just list down the process what needs to be done. So as I mentioned earlier, once the washing machine is turned on, wash input goes either like filling the particular water with particular temperature. So in countries like India, the water temperature might not matter as such, but in the cold countries or Western countries where you need to have a heater inside the washing machine which needs to heat the water, or you need to get the hot water tap connected to it, or something like that will be there. So there are multiple variables. So while designing a product, the company should take care. So it is catering to the larger demography of the whole world in order to have a better solution. So what they will do is their control algorithm will be having two modes, where in which for the cold country mode and for the normal countries like India. So they'll be reducing number of variables to have the better control system. So whole digital electronics concept, once the whole thing is realized, they might put it on a microcontroller, or they can even realize with a digital ICs what we use in labs like 7400. So that depends on the scale and viability and how redundancy and all lot of other constraints will come. So and life of the product and all those things will come. So then when the washing machine is full, run the motor and turn the drum. So yeah, this also there also the multiple parameters come up, like saying that what RPM it should run. So let's say it is spinning for the drying, then it will run at a faster speed. So it's just washing for the basic rinsing, then it will run at a slower RPM. So all those things has to be taken care in the sequence of operations. So once everything is done, drain the water out using other pumps. So we will just see how we can use simple Karnaugh maps to like realize it in a digital circuit. So like for example, here I'm showing like hot water and cold water and pump and all the motor, all these things. So these are different variables in our control systems and how we are controlling them. So this is how the basic thing works. Like how, here I'm keeping everything as like very basic and practical here. I'm not considering the RPM and PWM of the motor. All those things are not being considered. It's just enable disable cycle of the whole control system. So when you realize like in the right side, you can see the truth tables for the particular things, like what are the conditions and all those things. So ultimately you'll be having something like this at the control realization. So in the left bottom, I have solved the whole equation in a Karnaugh map, where in which you can see that the whole equation gets reduced to these small four parts of this equation. Then we can realize them in the left side. You can see that three NOT gates are being used. Then after that, AND gates are being used to get the final AND gate as an output. So like if you write it in a code, you can simply write it as a state machine in a code in a microcontroller. You will be able to realize the whole control systems of the washing machine into a simple output like this. So this is about the washing machine thing. So currently, you might have seen in your home washing machines also, there is a word called fuzzy. Fuzzy logic has been implemented here, or fuzzy control. So that fuzzy control is basically deals with the amount of water to let in and amount at which the RPM of the motor should be controlled for the dirt level and all. So it uses basically multiple sensors to sense the dirt level. It's a optical sensor kind of mechanism where in which it senses the dirt level, and based on that it will change the RPM. Like if the clothes are too dirty, so it will adjust itself accordingly and put more water and put like more concentrated detergent and all that thing. So so basically in a way it says that it's a smart fuzzy control system. So back in the days when it was introduced in 1980s and also it was a buzzword. So when the washing machines came out in 2000s and also they used to specially mention it as a novelty, saying that fuzzy controlled washing machine kind of thing. So now it is kind of normal, which is like more simple washing machines. Like washing machines are way more advanced. Some even may have connectivity to the internet and all those things. So yeah, let me go on to the next case study. So you might have seen these kind of large displays. So what do you think the technology used here maybe? What technology will be? Like technology I'm asking in terms of display technology, like LCD, LED, OLED, like that. You can put your answers in the chat box. Like I'm asking about the base technology of a huge large panel display, which you're right, it is LED. Projector might not be the case, because in the broad daylight you'll not be able to see the proper projection of the thing on the screen. You'll need such a bright light, so it's a waste of energy, and it emits a lot of heat in the like projector lamp itself, so it's not efficient that way, to have such a big screen. So LED is right. So basically, all the whole display is made up of small LED matrices, which are like easily replaceable. So you can put a LED matrix and put it in number of series and columns. You'll be having a huge display. So basically, it's like your phone having individual pixels. Just like that, it will be whole bigger display with multiple matrices. So each matrix will cater to some rows and columns of the LEDs. Like for example, let's say each individual matrix has 100 LEDs, then it will have 10 rows and 10 columns. So if you put 100 such matrices, you will be having so much big display with a lot of these kind of small things, like small LEDs. So that is the thing. So QLED is basically it's based on LCD only. The technology is quantum dot LED, they say, but it is based on LCD only. You can, it's a patented technology by Samsung, I believe. You can read upon that for more information. But it is not as efficient as OLED, because the OLED individual pixels are being lit, and you'll save a lot of energy in terms of the area where the actually there is a black. So here you can see there are some areas where in which the complete black is there. So you may turn off the LEDs there itself and only turn on wherever the required positions are there. And even in the LED matrices, there are RGB based LEDs which are not doing the same method as OLED, because in RGB combination LEDs, some combination of RGB color is being used to display the black color, so which is not exactly the power saving mode. So that is there. So basically, the idea behind this is the matrix displays. So let's imagine so many matrix displays are there, and you should be able to connect everything to a microcontroller or a microprocessor. But do you have those many GPIO pins, like the pins to connect? No, right? What exactly will be the digital electronic solution of this part? So what digital electronics component can be used here in order to have the display on, like in order to light all the pixels at once? You don't have that much in number of pins in your devices, then what else you can use? And putting each single microcontroller for all the individual matrix, it doesn't make sense, because you'll be end up having a lot of like a
Can you
lot
use
of
encoder, bro?
microcontrollers. Yeah, so what kind of
Encoder.
encoder you're talking? Okay, so basically the idea here is, even if you encode, right, you'll be encoding information. Encoder basically takes more information and put it and sends it out in a single pin. So you want something like a decoder kind of thing, like a shift register. So here is the funda behind this. This is the individual. In the left side, you can see that the individual matrix of that whole big LED display I am showing. So this will be currently, if you run it using single microcontroller, then it's a single matrix display running on a single microcontroller. You can have multiple of them using a shift register, basically. So here you can see that in the shift register, uh, you can see my cursor, I believe. In the shift register, you can see each data is, let's say the 14 is the data input pin and 9 is the data output pin. Output of the each individual shift register is connected to the next input. So in this way, you will be able to shift the data one after the another. So you will have to sample in such a high frequency, so you will be able to display whatever characters required in a whole lot of display. So to make this thing as a simple thing, I'll explain you using the BMTC matrix display, where in which it displays the destination and the source and the bus number and all. So let's say we have something like this LED matrix on the BMTC. You can see that the data crawls over so that one can read the complete data from, let's say it is going from one point of the city to other point. So the data scrolls just from left to right, like that. So that is currently being done with the help of a shift register. Basically, you have a single microcontroller. You send data to only clock and these pins, data pins, and you'll be sending the data to the next one on the rising edge of the clock. So this happens throughout, and you'll be able to see the lot of basically these pins which are there in the which are being used for the lighting up of the LEDs. Individual LED matrices are controlled through a microcontroller. So that's why you will be able to completely control the whole display. So the basic idea is, using shift registers, you will be able to control the whole bigger display. So with the help of shift registers only, you'll be able to realize how many ever big matrix display you want. You can realize them, and it is hot swappable. You can directly remove one of them and put back one more. And if, let's say, if you are having a lesser screen size, you can increase the screen size. All those things can be done. Just need to ensure that all the data being sent on a right edge of the clock. So that is the basic idea behind the large matrix displays. Okay, so this is something interesting. So let's say you are sending an information or an optical fiber or a electronic cable, and due to some external noises or magnetic fields, some data you might be sending like ones and zeros might be zeros and ones. So this will create an error. Let's say you are sending an image which is having some 50 kb of memory. So, but you send the image, but that whole 50 kb is converted into arrays, and each arrays will consist of single binary blocks, and each block will be sent individually, like 8 bits. So this might take a more time, but still you'll be able to send the data. But in this case, what happens is like whenever if you are sending the information like this, and due to external noise, if you send the information like in a wrong way, so you'll end up having the images like this. These white spaces say that the data there is one instead of. So in a grayscale image, the whole thing is actually ones and zeros, black and white. So instead of white, there is a black, and instead of black, there is a white. So in that case, what happens? This thing on the image on the left, you can see. So there are a lot of errors in the image. So due to which this issue has happened. So error correcting codes is one technology which is being implemented in the use case here. So well, like in future you might study about this. There is one course called Information Theory and Coding. There you will read about the Reed-Solomon coding and Huffman coding and Hamming coding, and all those things are there. So this is just a idea what I'm telling, like how the whole technology works in this. So in this one, Reed-Solomon coding is being used. So basically, like whenever there is data which is being sent, we'll also send it with parity bits or error correcting codes. So which will tell us odd parity, even parity, and some kind of our own algorithm which contains the different methods to tell the error. If there are errors, then it will inform the uh, like if the code consisting like there will be code along with the like let me show in the next this thing. So this is a matrix like from x1 to x11 is the data matrix, and p1 to p4 is the your parity matrix. So with the help of k maps, you will be able to easily generate this error correcting codes, and you will be able to recover the image. So with the help of k maps actually. So basically so you might have seen k maps in the in terms of table here in the right, but actually like that's why you might be thinking why we are grouping the four external points there like that. So in 3D realization, toroidal k map looks like this, and here you can see all four are very near to each other. That's why we'll be grouping them like this. So this is a toroidal 3D representation of a k map. So basically, the K-maps is the key here. So K-maps is being used for the easy generation of error control codes. So that is the thing. Yeah. So yeah. So let me go on to the next case study. So here the case study is about the. Can you guess me? Can you guess what exactly these are? Like what are the? Sorry. Can you repeat?
Robotic arms.
Yeah, robotic arms, correct. So basically, these robotic arms are being used in all industries, like automotive industry, like mass manufacturing industry, all those things. So, but uh, in order to precisely control them, like with an accuracy of 1 centimeter, 1 millimeter, like that. For example, let's say there is a soldering robot in a industry where which is solders all printed circuit boards. So, but like currently the components are getting so smaller that if you are using these kind of industrial robots, you need to have such a precision level of like let's say 1 millimeter in order to perfectly solder that particular component. So if you move a little bit away also, it might damage other components also. So basically the precision is very important key here. But in order to have a precise movement, you'll have to get the all feedback from the sensors. So how do you basically get the information back from the sensors? So let's say you are controlling a motor So like each joint will be there. So there will be one joint here, one joint here, one joint here, one joint here, like that. So, but if for each joint there will be a particular individual stepper motor or a servo motor which is being used to control that particular movement without any inertia. So what makes them different, the stepper motor or servo motor, is they can precisely stop at that particular point. So in terms of using different steps, you might come across the stepper motor in your microcontroller course, controlling the stepper motor using number of steps. So I'm just giving an example here. So for example is a normal DC motor, maybe or AC motor, maybe a mixie or a fan. Even after stopping, it will run for like 5-6 revolutions more. So that is due to inertia, whereas that is not the case in terms of stepper motor. So if that was the case, then instead of soldering one board, you might end up soldering somewhere else. So that is the issue. So we are currently using something called as a stepper motor or a servo motor with or even some brushless DC motor with the precision control, like for example, which is being used in gimbals. Gimbals are used for the photography purpose nowadays, to have a smooth movements. So in the smooth transition inside the video or some just to avoid all the noise and vibration. So gimbals use brushless DC motors. So with a very good close control loop system. So everything uses here close control system with a proper PID tuning. PID is your control system part. So you might come across this in your control system. This in order to sense the location or the angle of the each individual joint, we need something called as encoders. So here what we are talking about is rotary encoders. So I'll go to the next slide. So basically rotary encoders, there are multiple technologies, magnetic based rotary encoders, which will calculate in terms of movements of magnets. And like for example, for the case of digital electronics, here I'm choosing the rotary encoder with optical input. So here you can see in a first image. So there is a rotary encoder which has an LED and phototransistor system. So you can see there are black dots and no dots on the circle. So whenever there is a black dot, which produces a hindrance on the intensity of the image, intensity of the light being light being put on the phototransistor. So what happens is the amplitude will be a little bit lesser in that case. So since the amplitude will be a little bit lesser, so it will be mark it as 0. Then what happens is like for the normal one, we can mark it as 1. So if that is the case, we can easily count and make the angle, and we can even deduce the at what particular angle the whole thing is standing at. All those things we can see just by reading the counter. So let's say if you start from 0 and you have 360 for 360-degree resolution, you will be able to particularly tell that this is at exact 90-degree, this is at exact 95-degree, like that. So with the help of this, you will be perfectly be able to balance your motor's position, and thereby balancing and reaching the exact endpoint on the place where in which it needs to solder or weld or anything like that. So that is the particular application when being used in the case of industrial robots. So this same thing follows for a lot of other things also, like in terms of note counting machines in a bank maybe. So there will be these kind of rotary encoders running, and number of nodes passed through that encoder. So it will create a optical hindrance, and thereby you can count and you can directly show on the counter saying that this many nodes have passed through this thing, and it will perfectly count that many number of nodes only. So that is the main technology being used. So in terms of medical industry also, there are a lot of ways where you can use this optical method. For example, PPG sensors use these kind of things, wherein which PPG stands for photoplethysmography. You might have you might have seen this in a lot of these kind of smart fitness bands, wherein which you will have a sensor to read your heart rate. So basically, what it does is it sends out a light signal, and there is a phototransistor just next to it. So it will look back for the reflected signal, wherein which the reflected amplitude will change based on our blood flow. So there might be like for every contraction and relaxation of the heart. So the blood flow will reduce and increase. So based on this, the heart rate is calculated using the same technology. So you just run a counter for a particular amount of time. You may not need to run for 1 full minute. You can run for like another 5 to 10 seconds, and if you see some 6 beats for 5 seconds, and then extrapolate that data to for the minute, and it just show the heart rate. So that is the main idea behind these kind of methods. So yeah, that's all from our side. Let me know if you have any questions. You can either type in the chat window box, or you can put.
Hello, students, you can directly interact with the speaker. You can otherwise you can type them into the chat window also. Okay, if not, thank you once again, Vishwas and Shashank, for wonderful information about this case study of digital electronics. It really helped for our students to do the project and also to attend the hackathon competition or some other competitions using the digital electronics. So it's a wonderful talk. Thank you once again. Thank you, Nanda.
Yeah,
Yeah,
you're
thank
welcome.
you.
And thank you all for attending. And just feel free to contact either of us if you have any further queries.
Thank you.
Yeah, thank you.